Right. So like I said, we're talking today about data types, right? Data types. There are quite a number of data types, but we'll just talk about the main ones. And I think we'll just talk about the four main ones, but there are quite a few. So the first one is the string data type. And there are quite a few variants of strings. Then we have numeric data type. Numeric. Then we have Boolean. Boolean. Then we have dates. We have dates. These are the four main ones that we'll talk about. We've actually talked a lot about number four, but we would again revisit it to see just one or two more things. We have a few others, which we will not really talk about, but just so you know all this. Did I spell that right? I think so. We have XML data type. You might be privileged to maybe use XML data types in future if you progress with SQL. We have COLB. I would explain these in time. We have BOLB, and we have JSON. So these are the ones we will not really talk about, but I'll just explain what they are briefly. Right, so let's talk about strings. Strings. To do that, let me use so what's a string is any number of characters of variable length. Any number of any character at all is a string. So alphanumeric, so a mix of characters that would form a string. But how are these represented in a database? That is the most important thing that we want to actually, as we look at these data types, how they are represented in a database. Now, whilst as data analysts, we might not necessarily have to know what these things are in a database. It is good to have an idea. Reason being that assuming you are in a greenfield environment where you have to then build the database, how do you impute data into the database? How do you ensure validation of data? How do you ensure that you are assigning the correct amount of memory to the data that you are imputing? Right, so let's have a look at some of the, I'll just use a few here. If you look at, can you all see my screen very well? The the columns that I've opened here, can you see it clearly?
Yes.
Okay. So we have person ID and it is indicated here as int. That's a data type. We have employee number. It is indicated as nvarchar or nvarchar. We have start date. It is indicated as date. We have title. It is indicated as varchar or varchar. Forename varchar. Birth date. Gender car. Address ID is int, etc. Okay, let's take another database. Let's see what we have here. Here we have currency key as int. The PK here simply means is the primary key. Currency alternate key is ncar. What do these things mean? Currency name nvarchar. What do they really mean? That is what we want. So as we take these different data types, we would try to give meanings to how they are represented in the database. Right. So let's have 1.1. 1.2. 1.1. We can have under strings. So this everything under one has to do with strings, right? The first type of data type we see under strings is what we call the varchar. And that is any variable length of string characters, any characters of variable length. That is why it's variable, varchar, variable character length. That is simply what it stands for. So that is varchar. It doesn't matter. It can be in lowercase. It doesn't matter at all. Right now. So if you are setting up a database and you have a data type that is varchar, what memory space do you need? These are the kind of things we want to talk about today. Now, varchar can take it can take character length up to 8,000 in SQL. So this can take character length up to 8,000. Now, each character takes memory space of 1 byte. Character. One byte. 1 byte. So 1 byte per character, right? In an SQL server. Okay. So when you are assigning, let me see. Vaka. I'm looking for Vaka. Okay, none here. Let me see this place. Just anyone. Okay, none here either. Let me go to this table. Let me come here and see. I think I should get some here. Okay, Vaka. Right. Now, we can specify when we are imputing or when we are creating a database, we can actually specify the number of characters that we want to that we want to have in the table. So for example, if you look at forename here, it says Vaka and then 30. Whilst this can take up to 8,000, you really don't want all of 8,000. I mean, I can't come across a word that would be 8,000 characters long. I've not come across one yet. I'm not sure whether you will, but if you do, then that's okay. So what happens is that if you create the table, you can assign you can restrict the number of characters that's the string can have, or that a data type can have. So in this particular instance, for example, you will see that we have forename varchar 30. What this simply means is that this forename here, any forename in the database can have up to a maximum of 30 characters. So if it is more than 30 characters, the other characters would simply not show when a query is run on the database. Right. So that is for varchar. The second type that we have also come across just a while ago, I believe you saw that, 1.2, is nvarchar. Nvarchar or nvarchar, depends on how you want to pronounce it. Right, this is also variable character length of string. The difference between this and the first one is that the first is used mainly for English characters. The first is used mainly for English characters, whilst the second handles mainly non-English characters. So you can handle languages like Russian, French, um, Hebrew, Arabic, Korean, Chinese, things like that. So the second one can handle all characters, as a matter of fact, both English and non-English. Variable character, string, but can handle both English and non-English. Right. Now this takes up to four, it takes half the, it can take half the space. It can only take half of what VARCHAR can take. So this takes 4,000 characters. And handle up to 4,000 characters. So the settings here, for example, that you see, end varchar, end varchar, end varchar. So this setting here has been, the setup here has been made with a view to allow for non-English characters to be entered into the database. Then we have the car, simply car, or char. Now, this simply is a single character length. Single character length. Single character length. And this is mainly used when the exact number of characters to be entered is known. When you know exactly what you want to enter, then yes, that's when you do that. Right. In most database servers, if you do not specify for varchar, if you do not specify the number of characters, it would automatically default to 30. But like I said, it can take up to 8,000. And same for nvarchar, can take up to 4,000. But we really, really do not want to, or we may never come across a case where we would have to write code of characters of 8,000 and 4,000 and things like that for just single words. Right. So if, for example, let's run something here. If, for example, I decide to restrict to change the setting here, you can change the setting here can be changed. Let's see. Let's just run an example and see. Let's see. Select all. Okay, let's see. Select. Let me use this table. Select first name. First name. Select first name from. Dim employee. Okay, if I run this thing here, if I run this query, you see that it's giving me all the just the first names, right? It's giving me just the first names. But assuming I don't want to show all the first names. I don't want to show every character in the first name. Assuming I just want to show the first three, I can actually restrict that. I can actually do that. So let's see how that goes. What we do is use the word cast. Remember, we came across the word cast is it last week or last 2 weeks? I'm not sure when it was that we came across that.
Last week.
So cast first name. We use cast to either change the character type or sets or ask the data type to behave in a particular way. So first name as varchar. It is specified here as end varchar, right? Okay, let's do that. End varchar. Three. Why is this? Why is this? Let's see. First name and varchar. Why is this underlined? Let me see. Microsoft Server Manager. It's not defined in the system. Okay, let me change the source code and see if I can do that. Select for name. Employee for name. Select for name. For name. Okay, select for name, cast for name. Why is this underlined? From employees. Forename expecting invalid. We've used the correct name, forename, cast forename. Forename, select forename from
The
employees.
employees, the E is small letter. Does that not matter?
It doesn't matter.
Okay.
It's not case sensitive actually. I'm not sure what has happened. Is this connected? Okay, let me connect. Maybe I'm not connected. Let me connect to my database. Let's see. Yes, somebody has their hands up. Miriam.
Yeah, my question is actually not what you're teaching us. I just have a curiosity and I thought I should get it clarified. So if I want to, I could see from your screen now, yeah, I could see when you look at the top of your screen, there are various sheets that you worked on previously. They're showing. So if I want to have that, what do I do? I'm thinking,
All you do is create a new query.
yeah.
Click on
So
this, and
if I
a new page, a new sheet would open.
but if I close it down, whenever I open it, I don't get to see them anymore.
Because you haven't saved them.
You have saved them, but it doesn't come up automatically. Do I have to
All
whenever
right,
I
so
go?
it would have saved in your either documents or local drive.
Okay.
So when you go in there,
Mhm.
let me see if I can. When you go in there and then you click on I don't know where mine is saved actually. I'm not sure where it is saved. Let me see. I'm not
So it
sure where
doesn't
mine
save
is.
automatically like Tableau, like you just go on there, you just you can see what you worked on the previous sheet.
So for example, me, if I just go here, I get what I've worked on.
Yeah, that's actually what I want, but I don't have it.
Do you close it, right?
Yeah, what
You
I
should
save
actually,
it and
once you've saved it, you should have it actually.
mm,
Once you've saved it, let me see. Okay, let me stop sharing now and then let me open a page and then let me see if I can open another let me get rid of this. Let me get rid of this and start again. Okay, so let's say we select forename. Forename. I expect it to come up. Okay. From employees. 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 Okay. So let's do a cast for this. Cast. Cast forename as varchar. Or 3. Okay, I think I know what happened. The first time, I don't think we selected I don't think we selected a column. We just went from select then cast. So I think that must have been what created the error. So for example, if we run this, before I do that, let me comment this out so that you see the result for this one first. Right? So this has got characters more than 5. Let me even make it 3 to make it more explicit. So if I uncomment it now and then run it, I want to create a different column for that. Okay, let's run it first. So you see it has cut off some of the characters. So we only have everything as 3 characters. 3 characters. Now, the flip side to this is that if you set this, for example, to 30 and run, it will produce everything up to 30. Just so there aren't many names that would have 30 characters, except maybe you are from, I think there's a particular group of people who have very, very long names. I think the Sri Lankans, they can have very, very, very long names. So yeah, so that there's that possibility. You can set it to 50, like it's set here in the dim employee table. You can set it to 50. Now let's do the same thing here and see. I'm not sure. I think let's do this here. So if we run this too, we'll get the same thing like, okay, let me set this to 4. Right? So that's what we have. It would be the same thing if we used NVARCHAR. It wouldn't matter at all. Mind you, NVARCHAR takes care of both English and non-English characters. So we would have the same result. We would have the same result. And in much the same way, if we like, is the gender here? Let me see if this has gender table. Right, I want to do something on gender using just car. We know that car is 1 character, right? Single character. So let me change my data source. Because I can't see anything with, oh, actually, I can't see anything with 1 character in this table. I can't see anything. I can't see a car. No, I can't see a car here. So let's change the data source to this one. And then run another query and see what we would get out of that. And we know this is one character, right? So you see we have I hope you know why I put the X there. Without the X, it becomes a keyword, right? So I just wanted to differentiate it from the keyword. That's why I put the X there. Right, so that is for strings. So strings can be either variable character varchar, nchar, or char. And we know that variable varchar can take up to 8,000 characters, and varchar will take up to 4,000, whilst char is just single character length of data. Now we can also have char as text. We can cast as texts, and text would normally, if we decide to set it as a text, it takes text, string as text. What figure will this be? 147, 483, 647. This can take up to characters. Text. So that will be more or less like a book, isn't it? This is over, it's like, is it 2 billion? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's about 2 billion. 2 billion characters. So that should be more than a book. That's quite a huge thing, right? So we can also cast something as a text. If we can just say cast. Select. That just gives us this. So whatever we put here, it returns it as a text. It's what is here that has come up there. Okay, now let's go to numeric. So that's the second part too. We have different variants of this also. 2.1. We have what we call exact numeric. Exact numeric. We have what we call tiny int. We have small int. We have int, which is what we are used to, isn't it? And then we have big int. So what is the difference between these ones? Exact numeric will just show the exact number of characters that you want it to show. Now, tiny int is used for numbers between 0 to 255. Small, oh no, where did I put this? This should be tiny int. Small int takes between 32,700 and actually minus. It can take from minus 32,768 to 32 positive 32,767. So if you add these two up, you can add these two up, and that should give us what? About 64,000, right? No, about 65 something, if I'm not mistaken. Let's add it up and see. Let me add it up. Thirty-two, 768 plus 32,767. So that can take up to 65,500 and 535. Int takes, int is what we are used to, and int can take any number of characters. It can take any number of characters that we, no, I'm a bit wrong if I say any number of characters, but it can take a huge number of characters, a huge number of characters. It takes, I'm not sure if you can say what this number is. So int takes up to this. Big int, like the name implies, is big and would take anything. Any number of numeric characters, right? Any number of numeric characters. That's what I mean here. Okay. So let's see how we can use this or this information. Now, that's the reason why int is the most popular is because it covers quite a good range, both negative and positive numbers. We hardly use the other ones, but it's just so you know that it's there for use. We hardly use them. So if we, for example, say that select cast. What do you think this will return? What do you think this would return? Can anybody tell us what this will return? What this query would return? It will return 1 because it's within this range. Right. Now, if we were to go outside of this range, let's see what would happen. Let's try that and see what would happen if we go outside the range. So it creates what is called an arithmetic overflow. It doesn't recognize it because it is not the character type. It's not that data type. So it doesn't recognize it. In much the same way, if we decide let's say let's take another character type, 20,000. What will be returned? This belongs to small int, right? Small int. Will it return it? Will it execute? Yes, it has returned it. So it recognizes it. And even if we were to use int for this, it would still recognize it. If we use int here, int would recognize all of this as well. So that is why int is the most commonly used. But assuming you go into database administration, it's good for you it will be good you know these things, right? Int would still recognize that. And big int, like the name implies, big int is really, really big. This can take characters. Oh my days, the characters are big. It can take from, I don't know how I would read this out. 233, 372. Actually, I have it copied somewhere. I have it somewhere. Let me just copy it and paste. Where is it? Big int, where are you? Where is big int? Yep, that's big int. So it takes 2 raised to the power 63. So that means 2 raised to the power 63 up to 2 raised to the power 63 minus 1. That means you multiply 2 63 times. That is a really, really, really huge number. A really huge number. So this number is what? This is thousands, millions, billions, trillions. What is after trillions? Is it quad something? I've forgotten. And then after that, so it's really, really huge. And it's both positive to negative. So it goes negative this way and positive that way, right? Minus 1, okay? So that's quite a huge range of numbers. I'm not sure we would ever come across or we would ever have to deal with anything like that. But just for computer memory's sake, we need to know. Right, so another number type. So this is where we deal with exact numbers, right? Exact numeric. So actually this should be 2.11, 2.12, 1.3. Then we have numeric decimals. Decimal numeric. Now this one is used in representing decimal digits, where there are decimal numbers within a number. But how does it work? We can specify how we want the number to be represented. So the number of digits, decimal, can be rounded up or down. Can be rounded. Right. How does this work? Assuming we have to do a division like we did salaries some time ago. We worked out salaries some weeks ago. And we want to specify exactly how we want our results to be represented. If, for example, we have 37.9 divided by something like 2.3. Let's assume this. Let's assume we have that. Now, to set this up, what you do is you you would indicate how many total digits you want your result to return. So assuming I want, you might not know how many total initially. So just set to play safe, you know that 37 divided by 2 is about 18, right? So you are sure you would have two whole numbers, right? Assuming you are not sure, just set this up as 3. And then the second character that you set up represents the number of decimal places that you want. Right? I think I have to put as numeric. Right. The first character here indicates the, no, let me make that 6. Reason being this, the first character here represents the total number of characters you want in the output. So we know, for example, roughly, let's do a rough calculation. 37 divided by 2 would give us 18, whole 18. That's in whole numbers, right? So we know for sure that we will get 2 characters minimum. But we also know that there will be decimals, right? We don't know how many. So we do not know how many characters altogether there will be. The first number here represents the total number of characters we want in our output. The second is used to represent the number of decimal places that we want to have in the output. So if we, for example, run this, this is what we have, 16.48. 16.48. Now, we said 6. It didn't give us 6 characters, but it doesn't matter. What matters is that we have put enough value here to account for the total number of digits in the output. So now that we know that it's 4 characters, if we were to put 4 here, we would get the same answer. It wouldn't change at all. It will give us the same 16.48. However, if we were to put 3 here, for example, if this should go beyond, if there are other digits, it would show the digits up. Why? Okay, so it's highly likely that there are no more digits. So it's not, that's why it's not working. But I think you get the idea. It should work. Let me use something else. Let's see if we have, let me say we have 22.5 divided by 1.1. Let's see if we run this. Let's see what we would get if we were to run this. Okay, if we let's set this to 3 and see what would happen if there are other characters after the 5. Okay, I think I see. I know why that is happening. Do you recognize what just happened? So when we did this one and then I set this to 3, it should still work. But you see, I have said that it should return 4 characters all together. Now we know that the first the integer part has 2 characters, and we are asking it to return 3 decimal places. So the system is confused. So this should be a minimum of what? 5. Do you get it? Should be a minimum of 5. So if we do this, that should work this time around. That should work. And if we were to do this, make this 4 characters, so there are how many, returning a total of, so let's say this one is, how many characters altogether? 2 plus 4, at least 2. That is the integral part is 2. And we are asking it to return 4 decimal places. So we should have at least 6 characters altogether. So let's just set this to 7 to play safe. So that works, right? Any questions? Any questions? Float. Float is the same as decimal. But let's see how that word works also. Float is also decimal. So instead of using the word numeric, we can set it as float. But that is specifically decimals. Whilst numeric can be either decimals or non-decimal. Let's assume we have 1, 2, 3, 4 point 1, 2, 3, 4, 5 as float. What will this return? This returns exactly what we've asked it to return. It returns everything as float. In the same way, we can use we can say, for example, return, though you wouldn't, let me just use a whole number here, 15 as float. It will return 15. No decimal points because there is no need for it. But logically, it is accounting in the computer memory it would account for the possibility of this being a float, of this being having decimal characters. And the third data type is Boolean. That's true or false, or one or two. One and 0 and 1. Yes or no. True, false, yes, no, 1, 0. Boolean. True, false. One, 0. Yes, no. So this is the case where we have just binary options. Two options, either true or false, either 1 or 0. Remember, those who would have done computing long ago had to actually write characters in binary digits. They needed to know how to convert characters into binary code, into, I believe all of us here did something in binary numbers when we were in secondary school, right? So we learned how to change from decimal, that is base 10, to base 2. We know that base 2 is just ones and zeros. So computer language is written normally in ones and zeros, right? So that's where the Boolean option came from. So that if we were to say, if I cast 1, right? Before we go on, can somebody tell me 1 and 0, what character type is this in the computer memory? Or how much space does this take in a computer memory? Does anybody know? Does anybody know? Pardon?
Tiny int.
No. In the I didn't say what character type. What's memory space? When we were here, I said something about, where is it? Where is that? I mentioned bytes, right? What is
Maybe kilobyte.
what is the memory type, the memory before byte?
I forgot.
Okay, that's bit. Bit. 8 bits make 1 byte. So here, a byte is simply 8 bits. So 1, 0, 1, 0, all these true, false, yes, no, that's 1 bit. If I were to run this, it would still, because 1 is actually, it falls within this memory space, would just give me that. But assuming I use something, a different number, if I were to use 0 also, it would be the same thing. Zero would also run perfectly. Zero would run perfectly. So both will run perfectly. Let's try true or false. Let's see true, false. Let's try true, false. Let's see true, false. I'm not sure if this, let's see. Let's just see how it would come out. Yeah. There is an error somewhere. Did you see just what happened now? Let's see if this would work out. Okay, so this didn't work out. So it sees this as a string. It sees that as a string. But you get an idea of what the Boolean option is. In the same way, if I were to say, for example, use the number 2, will this work? Will it recognize this? If I were to use, take note of what has happened. Why is this the case? So in all of these cases, it doesn't see these numbers as anything other than 1 or 0. It doesn't see these. It sees these as numbers. So in the computer mind, it says, is this a number? If it's a number, it's true. If it's not a number, it's false. So either way, it returns a bit, which is either 1 or 0. Okay. Right. So we are almost there. We are almost finished. The fourth type of data is dates, which we have actually dealt with extensively. So that is dates, but just a quick recap of something here. So we can cast date also, right? We can cast date and make it show as did we do casting of date? I think we did, didn't we? We can cast date. So if we say select get date, and then we cast this in a particular way. We want this date to, we know that get date would give us today's date, right? But get date would give us the date in date and time. So if we were to run just this one, we will get our results as today's date in date and time. Date, 22nd of March, 2024. The time now is 10:22. It's 10:24, 36 minutes. Am I right? 36, 10:24, 36 seconds, 703 milliseconds. Okay? Right. There might be the case where you do not want this time element to show. You just want the date alone, right? So you can again use casts. Remember we said casts is used to show how we want our data to be represented. So cast gets date. How do we want it to show? We want it just as a date. We want it as just a date, right? We want it as just a date. So, yep. And if we want it, we can also just get the date or just get the time element of get date. Instead of outputting everything, we just want the time element. And let's see what results we would have if we were to run these queries. So you see this here, the first bit gives us the full date in date and time. This one gives us just the date. And this one gives us just the time. So let me say as date. So this gives us the date and that's the time, right? So we are almost, we are almost done for today. Let's now look at the others. That's going to be quick. We spoke about XML. That simply is used in storing XML data. We will not talk about that. Storing XML data. I might just give a brief representation of how this might look. So if we have something like select if we have something like this, we can, for example, write code that splits this data up. Splits this data up into different sections. So we can have this split up into columns, for example. But we wouldn't actually look into that. If I have something like this is what would happen. It arranges them columnarly in a column. Right. So that's what that is basically is one of the uses of that. Then we have what is called club. So you remember we spoke about big int. So this is even bigger than big int. And that is character large objects. Character large objects. CLOB. Now this holds up to 2 gig of data. Then we have this is used for binary large objects. So in the case like this case where this Boolean here, where is that? In the case of this Boolean here, if we have a large number of ones and zeros, a really large number, then we can use this to store the numbers. Binary large objects. And then the last one we will look at is JSON. Who knows about JSON? So this is simply for storing JSON data. Right. So that brings us to the end of today's lessons. Anyone, any questions?
What is JSON data? What is JSON data?
What is JSON data? I did say that we would not go into it.
Oh, okay.
Right, but if you must know, it's it is a kind of programming language. It's the kind of programming data.
Okay.
Have you heard of anything? Have you heard of something called API before?
Yeah.
You've heard of API?
Yeah.
Have you seen API in progress? Have you seen it being worked on before?
No.
No. So it's actually JSON data is programming code. It's small snippets of code that comes out as programming language. Right? That is why it's beyond our scope. We wouldn't look at it.
It was good to
But just so you know.